All right. So we're continuing on with lesson 11, okay? Remember we were talking about linear equation in two variables. But do we really call it that? What have we been calling it? Standard form, okay? So we're going to continue on with standard form. So now we're going to be talking about, we're going to be wanting to write it a certain way, okay? So this first slide is going to look really similar to your last guided notes. So an equation in the form ax plus by equals c is called a linear equation in two variables, or what? Standard form. When we get into graphing, it's really hard for us to look at the equation ax plus by equals c and know where to start. It's just hard for us to graph. So to make it easier, we're going to convert that equation into slope-intercept form, which we'll get into in just a second. Because slope-intercept form is kind of going to give us some clues about where we're going to start and where we go to the next point.
We're learning about that in
Are you?
yeah, like intercept.
Yeah.
Intercept.
Good. Yeah? Okay. Then we only went over that, so I'll have Matt show you what's next, okay? Or what's on there. Okay, so slope-intercept form. It looks like y equals mx plus b. Okay? When we convert from standard form to slope-intercept form, it's going to be secret math code for, you ready for it? Ready for it? Watch it. Boom, solve for y. What does it mean when we say solve for y? What are we trying to do? We are going to try to solve for y, but what do we have to do to that equation? I have to get something by itself, right? I have to get what, Kate? I have to get y by itself. Isn't y by itself up there? Okay? Now, if you go back, I'm going to go back and show you something. Our equation ax plus by equals c. All right, that's standard form. And if you look here, they don't use the same letters. So if I were just to rewrite this, this would be mx plus b, and then we make this one. This one would still be the same. But see, now it kind of looks like that, doesn't it? They've just replaced ax with m. But do we have to use the same variables each time in an equation? No. No. But what is the same in this in slope-intercept form and standard form? What letters are the same?
B.
Shelby? B and C, yes, but what else? What's mainly the same? X and Y. Okay? Wait for it to pop. There you go. So make sure you put solve for Y down there at the bottom.
It's pretty secret.
It is pretty secret, isn't it? Oh, we're giving away that secret.
I don't know if I can hold that back.
Okay, we'll have to wait and see. Okay? So, go on to your next example, example 1. We have negative 5x plus y equals negative 4. Your bullet point down there, this is your spyglass, that's what you're going to write down there. Use your inverse operations to solve for y. Okay, so we want this equation, this is in standard form, we want it to look like y equals mx plus b. So we said we want to solve for y. We want to get y by itself. So how do you think I'm going to get y by itself? Think about it. Levi, what do you think I'm going to do? Bring what down? Bring down the y? I could, but I can also just leave it there. Jacob, what do you think?
Plus 5x.
Why would I do that?
So you get y by itself.
I am going to get y by itself. So I'm taking 5x. Is that negative or a positive? And what's the inverse of negative?
Positive.
Positive. So I'm going to add 5x. Is that it?
No, we have to do it on -4 too.
Good. I have to add it over here as well. I get y equals, can I add 5x and minus 4?
No.
I hear yes and no. Who thinks I can? I can add those. I can add 5x minus 4. I can combine those together.
Oh, yeah.
That you can? Alright, who thinks you can't? Kirsten, you were shaking your head no a second ago. So you think you can? Raise your hand. Okay. So who said that they think you can? Alright? Kay, why do you think you can combine these? I just want to know. Just curious.
Because if you put it in the calculator, it'll come out with the number.
Can you put an x in a calculator?
No.
No?
But you just have to, unless you bring the x down. Yeah,
No.
you just have to, once you get the answer, you just add x to it. I mean,
Think about it. Shelby, what do you think?
Well,
it's probably wrong.
but if you're going to -4 plus 5, then it's +1, and you just bring down the x, right? And then once you just divide by it.
No, what, think about it. This is one of the first things we kind of learned. Chloe, were you one of the ones that said you couldn't combine these? Okay, why do you think you can't?
Because -4 and 5x is not, they're not the same, like, -4 doesn't have an x in it, so you can't add it together or subtract it.
Good. -4, does it have an x? Does -4 have an x? No. So why not why don't I square, remember how we squared our terms with the variables? And circled the ones that don't have variables? Can I combine a square and a circle?
No.
No. So I can't combine those because they both would either have to have x or they just both would have to be normal numbers, like 5 and 4. Yes, Leland?
I think I know what you used to do. You bring down the y, or -4 down, plus, and then you put the plus 5x.
Okay, now I want it to look like that. I want it to look
Oh,
like,
well, other way, like that.
other way, what would come first?
Okay, it'd be 5x minus 4.
Minus 4. Since I can't combine those, I just write y equals 5x minus 4. That's my answer. That's all we're doing. How do you feel about that? That's not bad, is it?
Oh, my gosh.
Will it be always like that?
Huh?
Will it always be like that?
What will always be like
Like,
that?
will it always be like that with the 5x minus 4?
I mean, you might have different numbers, but it's always gonna be y equals some number times x plus another number or minus another number.
Okay.
Because when we get into graphing, it has to look like that. Do what? Well, we are solving, we're solving for y, but we don't have to find any numbers. Okay, we're just finding this. Okay, when you have that written, you need to get out, you flip over your whiteboard working. And if you needed a marker or eraser, does anybody need one? Should have got one, they were about here by the back. I will get you one, raise your hand if you need one. Anyone else need one? Hand raise.
Oh, me.
Here, I'm gonna flip it on over. I don't know if
I
it'll-
don't have any eraser. We didn't get it.
All right, so do this one on your white one working. Remember, I want it to look like y equals mx plus b. Sure. why did you subtract 3? Good. Just right there? Underneath as well as well. And if you need to, you can draw your line. Yes, next door you can. So then I get y equals, what do I write, Jacob? Negative 3x minus 12. Raise your hand if you got it right. Yes. Okay, good. How do we feel? Good. Brain hurting yet?
Yes.
Yes?
No.
I gotta stop the timer. I would let the timer keep going. I'll speed it up. I said I would, but I gotta go to the next thing. You really wanna see what happens though? Record? Oh my goodness. So,
Oh, I'm so
alright, on to example 2. This is your next box on your notes. You can erase your white one working. Your bullet point again is right here. Use your inverse operations to solve. Doing the same thing as before. So I want to get y by itself. So Kate, if I want to get y by itself, what's the first thing you think I should do? Okay? I would add 4x. Is this 4x positive or negative? So, good. So I'm going to subtract. Good that you caught yourself there. So then I get negative y. What's in front of the y there?
Negative.
A 1. So I'm going to write it just in case anybody wants to see. Austin, can I combine these two, okay? Can I combine negative 4x and 10? No, so what comes first? Negative 4x, then what? Plus 10. Good. Now I want it to look like y equals mx plus b. Am I done?
No.
Ooh, no. Why? Who says no? Kate, why do you think I'm not done?
Because you have,
I know, you're looking right at it.
because you have a negative 1.
Because I have a negative 1y. What should y be?
Positive.
Positive. So how am I going to get rid of that negative? Alexis? Divide by negative 1. But hold on. I can't just divide that by negative 1. I have to divide each term by negative 1.
Oh.
Do we remember what separates terms?
Additional subtraction.
An addition sign or subtraction sign? Good. Zach, you don't have this written down. This is on your notes. Alright, so what's negative 1 divided by 1? Negative 1. What do I get? Negative 5, negative 3a.
Positive.
So I'm going to write up here, y equals, what's a negative 4 divided by negative 1? Positive 4x. Now, pay attention to whatever your sign is right here, because that kind of tells you what this number is. So is this a positive 10 or a negative 10?
Positive.
Positive. So what's a positive 10 divided by negative 1? Negative 10. So my answer is y equals 4x minus 10. Fill that one on your notes. Keep your head up, please. I won't tell you again. That's it. All right. So that one was your notes. What do you think's next? operation I do here, -1. Not close enough. What operation, when you have a number next to a variable, what operation? Like if I just have the how would I normally solve that? I would divide, divide by -1, to have each term. Okay? That would just be what, just positive y equals, what's 2 divided by -2? 2 divided by -2. And then what's 14? There you go, you're done. Oh, hang on.
You set the
I'll
timer.
grab start timer, that's okay. Yes. It sure is.
I'm finished.
Oh, you're done? Well, how do I know if you're ready? Good. Just look at the sign and just have it where that's supposed to be. Okay? All right. Go ahead and flip over your everyone ready. Let's check your work. All right. Houston, what's the first thing you did? Add. Okay. Just there? On both sides. Good. So then I get -y equals 2x. Is this a positive 14 or negative 14? So I'm gonna do what? Good. Am I done?
No.
Jacob, what do I have to do?
Okay, then you divide -1 to both sides.
On both sides? So where else?
Under 2x and 14.
Good. All right. So then I get y equals, what's 2 divided by -1? Okay,
-2
good. -2 what?
x.
Good. And what's 14 divided by -1? Micah?
-14.
-14. So y equals -2x minus 14. Raise your hand if you got it right. Yes. Talk about it. Good job. All right. Let's go on to example 3. Okay, this should be on your next page of your notes. So flip over your page to example 3. There's your bullet point again. It's the same again. Use your inverse operations to solve for y. Now 4x plus 2y equals 10. Looky there, Destiny's on it. She's like, I got this. So Miss Destiny, what's the first thing you did as you keep working this? Okay, subtract 4x from both sides. Then I get 2y equals, what comes first? Good. Is that a positive 10 or negative? So I make it a plus 10. CJ, haven't heard from you. What do I do next?
Divide by 2 on both sides.
On both sides, to each what? What are these called? Starts with a T. Each. Does everybody remember? Taylor, term, each term. Okay? So Danielle, when you divided each term by 2, what did you get? What's -4 divided by 2? -2 what? Good. And what's 10 divided by 2? Positive or negative? So I do what? Good. Look at there, I'm even saving some people on the next one. Just hold on, hold your horses. We're gonna get to it, okay? I promise. Is yours finished? No. I didn't finish one thing else. You worked it out. All right. I'm gonna keep that up there so people can finish writing. But I'm gonna write your white one working problem. 9x plus 3y equals 18, all right, right here, so you can see. 9x plus 3y equals 18. Solve that one on your white one working. training, I left that up there so you can, I wrote it here, so you can, go ahead. Michael, you got this. Get two more questions for me, because I know you can do this. I mean, your choice. You wanna ask me now, or you wanna ask me later? Okay. So this should be what? That's 18 divided by 6. Okay? Leila, are you still working? Do you need to put a little bit on it? Can I call on you in a second? All right, flip it over your white one working. All right? Okay, what's the first thing you did?
I did minus 9x and did it to the 18 also.
Okay. Okay, what happens here? What's 9x minus 9x? Cancels out, right? So you get 3y equals, what comes first? Jacob?
Negative 9x. Plus 18.
Why is it plus 18?
It is a positive 18.
Because it's positive 18. All right, Zach. How am I going to get y by itself? Divided by what? 3. What do I have to do though over here? Is that it? And what else? And 18, right? Each term. Okay? So Francesca, do you have your final answer? Have the final answer? Okay, so what is it? Y equals, what's negative 9 divided by 3?
Y equals negative 3 plus 6.
Negative 3 plus 6? Or, I'm forgetting a letter. I'm forgetting a letter. It's negative 9x divided by 3. There we go. And 18 divided by 3 is what?
6.
Plus 6. Raise your hand if you got it right. Yes. Daniel, did you get it right? Yep. Can you handle that?
Are you
This is
kidding
too
me?
easy.
Are you kidding me? This is like 5th grade work.
Ooh.
Oh, you shouldn't have said that.
Uh-oh.
Kate, do you have a question, my dear?
I'm dead.
No? Okay, you're saying you got it right? Oh, good job. All right, erase your life working. We have 2 more examples. So, again, use your inverse operations to solve for y. Ooh, Kate, look at her, she knows. What's the first thing I do? Draw my line. I'm gonna switch over to red. I like red. Okay, now what?
And then they're gonna add 2x.
Why did you add 2x? Good. Is that it? Good. I get negative 3y equals, what comes first? Okay,
2x.
okay, then what?
Positive 15.
So I add 15. Good. Levi, what's next? divide by just 3. What's in front of that 3? -3. Divide each term by -3. Now, whoa. Oh, what, Micah?
You get a decimal.
Uh-oh. Can we have a decimal?
No.
No, fraction. All right, so turn -2 divided by 3. Turn that into a fraction. Well, what do you get? Raise your hand once you get it. I want everybody to put in their calculator. Raise your hand once you get it. Ooh, raise your hand once you get it. Matt, what'd you get? -2/3 x. And then what's positive 15 divided by -3, Jacob?
-5.
-5. Question. Does it really matter where I write this negative?
No.
What about if I were to write a negative here? I had a negative here and a negative there.
Yes.
What happens? Leland's shaking his head. Why are you shaking your head?
No, because either way, you said you have one of them, it doesn't make sense. Have two of them, it would.
What happens when technically I'm dividing here, what happens when I divide two negatives? Well, it becomes positive, and my answer's not positive. Just curious, just make sure you're all on your toes. Okay? All right. Do this one on your white woodworking. And we got one more.
After this, table.
Do we remember what we're converting to? What are we calling this? What's y equals mx plus b called?
Slope and intercept one.
Good. Keep going. Here's a little tidbit. If you have a fraction in there and it can reduce it. Simplify it. Get it into its smallest form, which you already did. You already did that. Because if you put in your calculator. Go ahead and flip over your red one, ready? Destiny, what's the first thing you did? Why? Because inverse operation, beautiful. I love the vocabulary. Then I get -6y. Do not forget that sign. That's really important. What comes first, -4x or 30? Jacob? -4x. Plus 30. Matt, what's next? On both sides? To each what? What are they called? What are these called? It starts with a T. Each term. Remember terms? Each term. Now, when I said when you see a fraction, like if I look right here, well, first off, what's a negative divided by a negative get me? Positive. So if I look here, this kind of looks like a fraction, doesn't it? 4/6 looks like a fraction. But can 4/6 reduce? Can that be simplified into what? 2/3. Is that a positive 2/3 or a negative 2/3?
Negative.
Ooh.
Positive.
Positive. Why is it positive, Leland?
Because the negative and negative.
Keep going. Negative to negative.
-4x and -6x, if you divide negative times negative or negative divided by negative to the positive.
Good. All right. So negative 6, Leland?
Where's that?
Right here.
Oh, you said a positive 3.
Positive 30
Okay.
divided by negative 6.
Oh, that's negative 5.
Good. Alright, Shane, you got it right. Y equals 2/3 x minus 5. Good. Alright, one more example. Alright, example 5. This should be on the back page of your packet. Again, inverse operations. Put that on the bullet point.
Uh-oh.
Uh-oh.
There's no number in front of the X.
So you have to
So you're gonna have to put a 1.
I'm gonna have to put a 1. Good job.
Yeah, we're smart.
You are smart. Chloe, what's next?
Oh,
What's the first thing?
I'm gonna say you do -1.
I would do the inverse, which is negative 1x to both sides. Then I get 2y equals negative 1x minus 8.
Then you divide it all by 2.
Divide every term by 2. What happens here? What happens there, Jacob?
It becomes a fraction.
It becomes a fraction. So what is that fraction? Negative 1 divided by 2 gives you
Negative
what?
1/2. Negative 1. Well, half.
Yeah, negative 1/2 what? X. So what's a negative 8 divided by 2? Okay,
Negative 4.
good. Write it down, please. Alright. Get your whiteboard working ready. Alright, do this one on your whiteboard working, that's your last one. And then I'm gonna have you do something else in just a second. Now be careful, just be careful when you're going so fast. We make small mistakes when we go too fast. Just be careful, we gotta remember those signs. So you haven't used your 2 questions. Have you been getting them right?
I forgot about it.
Have you been getting them right? Okay, very first thing I do, Shelby. Oh, what do I do first? Subtract x. Okay. And I get, and I saw this a couple times on a few of your whiteboard workings. You're forgetting this sign. Bring down the negative 5y equals, what comes first? Okay,
Negative 1x.
negative 1x minus 10.
Megan.
What do I do? Divide by negative 5 right here. All what? negative 5? Turns into positive what? 1/5. And see if I kind of look right there, it kind of looks like fraction, right?
Yeah.
Can't reduce, so I'm just gonna leave it. Can't reduce. So, negative divided by negative would be a positive x. Now what? What's a negative 10 divided by negative 5, Kate?
Positive 2.
Positive 2. So y equals 1/5 x plus 2. Raise your hand if you got it right. Yes. Okay. So, what I'd like for you to do, don't do anything yet. I want all eyes on me, please. I would like for you in just 1 second, somebody at your table, this is perfect time. Someone at your table needs to get out a piece of paper. You're gonna rip it in half. You're gonna do the exit slip for me. Don't do it yet. You're gonna rip that piece of paper in half. You're gonna put your name on it because people still fill their names on their paper. Your name must be on it or I can't give you credit. Okay? And I'm gonna write the problems on the board here. So go ahead and get out that piece of paper. This can be done silently. Okay, this does not require talking. When you're done with your exit slip, turn it into the basket. Sit down and wait patiently before I tell you the next thing.